All right, can everybody hear me okay? Perfect. So as a matter of introduction, thanks first for coming to the session here at Inforce. As a matter of introduction, my name is Patrick Woods, and I am the Security Assurance Lead for U.S. Public Sector here at AWS. And prior to coming over to AWS last year, I was actually the Missouri State Highway Patrol CISO, and in that role, I oversaw the CJIS compliance in the state of Missouri and sat on the FBI Security and Access Subcommittee writing the CJIS policies that we'll talk about today. So just so I can get a feel for the room, how many of you are in public sector today or supporting public sector? Okay, so how many of you are familiar with or at least are challenged or maybe challenged by CJIS or FERPA in particular? Okay. So what I'm going to go through today with you is kind of how we can use encryption to meet some of the more challenging aspects of CJIS and FERPA in particular. But what I'm going to cover is really something that you can apply to most public sector regulatory requirements. Just in the time frame, I wanted to pick two that are the ones that we hear the most from our customers about having challenges. One thing that I want to cover right off the bat is that this is not to suggest that encryption is the silver bullet to compliance with public sector requirements. There's obviously, as most of you probably know, there's a number of controls that have to be put into place to comply with these regulatory requirements, but encryption provides some, or simplifies that approach a little bit. It takes away some of the more challenging contractual requirements around both CJIS and FERPA, and as I said, we can apply this to more than just these two requirements. So we're going to walk through just real quickly, why do we encrypt? What's the benefits of encrypting? Some of the encryption challenges using legacy technology, and why encryption isn't just isn't the default. We'll go through a background of CJIS and FERPA, and then we'll talk about how to leverage AWS Key Management Service to achieve compliance and a more sophisticated security posture. So let's start with, why do we encrypt? So if we look at the data breaches since 2013 by the numbers, over 14.7 billion records have been lost or stolen in that time frame, and that equates to nearly 6.3 million records every single day. So, I pulled out statistically 260,000 records will be lost or stolen just during this session alone. And when we look at, of those records that were stolen, surprisingly, in 2019, only approximately 4% of the incidents involved encrypted data. So if we think about how different these breaches would look, if we were, instead of talking about stealing data in clear text, we were talking about that hackers got in and were able to exfiltrate encrypted data, that's a very different conversation than clear text data. And so this is why we need to start moving towards encryption being the default. And we'll kind of go through why this isn't the default today here in just a second. But let's think about the security gains that using encryption gives us. So one, it helps us enforce principle of least privilege. So for those of you that may not be familiar with the concept, principle of least privilege just says we should only give access to the folks that actually need access to the data, and no further than that. So giving access to just those folks that really need the access for legitimate reasons. And this, as we go through CJIS and FERPA in particular, you'll see that the principle of least privilege is actually one of the underpinnings of both of these regulatory requirements. So it also limits exposure to regulated data and sensitive data. Again, going back to principle of least privilege, it limits that exposure to only those folks that have a need to know and right to know with that data. It protects the data from outsiders, insiders, and third parties. So any of your service providers that may be building on AWS, AWS itself, where we don't need access to the data, we actually want to empower you with the tools to protect the data. So why don't we do it? Why isn't encryption the default? And when we look at CJIS in particular, I've been a part of conducting hundreds of CJIS audits of law enforcement agencies throughout the years, and we're still very much in a state where encryption's not the default. We rely on personnel and physical security a lot, and to some degree too much. But if you think about the culture in law enforcement in particular, physical security is kind of what they do, right? So that is the default today. Why don't we encrypt in transit and at rest in our own data centers? Largely because encryption isn't scalable across multiple disparate legacy technologies. So encryption's difficult, and when we look at the key management, which is a really important part of encrypting our data, and key management and proper key management is also difficult. That's why we see keys being stored in plain text outside of a protected environment, even when the data is encrypted, which virtually, defeats the benefits of encryption when the key is being stored right next to the encrypted data. So proper key management and managing your keys in a very secure environment is really important if we're going to go this route. So let's take a look at CJIS and FERPA, and we'll kind of see that there's some similarities and there's some important differences as well. So for those of you that may not be familiar with CJIS security policy, CJIS stands for Criminal Justice Information Services. The policies are actually written and voted on through what's called the Advisory Policy Board. And so when I mentioned in my background that I sat on the Security and Access Subcommittee, that was the Security and Access Subcommittee of the Advisory Policy Board. And this is a group of state, local, federal, and tribal law enforcement and criminal justice officials that all come together. They come together twice a year, and they vote and propose and vote on changes to the CJIS security policy. So this is one of the misconceptions about CJIS security policy, is that this is an FBI policy and an FBI mandate. The FBI is really, they have the final approval over these policies, but all of the policies really come up through a grassroots initiative where law enforcement or criminal justice agencies propose changes to the policy. And it goes much beyond just CJIS security policy, but as it relates to CJIS security policy, all of that gets assigned to the Security and Access Subcommittee, and then the full APB votes and makes a recommendation to the FBI director. From there, the FBI, once a year, publishes the new version of the policy, and they're responsible for kind of the stewardship of the policy. So you have the ISO program office out of the FBI CJIS division that provides guidance to the agencies that need to follow it. And then you have the audit unit, which goes out and just makes sure that everybody's following the rules uniformly throughout the United States. So the policy, like I said, is published annually by the FBI CJIS division. It's usually around this time every year. So we just saw version 5.8 get published by the FBI within the last few weeks. And so we see, sometimes fairly minor changes to the policy, and then other times there's more significant policy changes. So, in the last 10 years or so, some of the more significant changes was requiring advanced authentication or two-factor authentication when accessing from outside of a physically secure location. So that was one that the law enforcement community and criminal justice community kind of had a hard time implementing, but over time it's been implemented, and the community is much better for it. So the governance and enforcement of this policy is also distributed. Much how the APB comes together to vote on these policy changes, the governance and enforcement is split between the FBI CJIS division. As I said, they publish, they audit on a national scale, and can provide some guidance. Really, where a lot of the work goes with CJIS and why this is such a distributed policy is at the state CJIS system agency level. So every state in the country has a state CJIS system agency. And this is the agency that's really responsible for how the policy is going to be interpreted and how the policy is going to be implemented in that particular state. So for service providers that provide services across a lot of different states, this is a significant challenge because each state takes their own individual interpretation, and it takes a lot of work to work with those states to determine what is the best way for us to comply with the policy in that particular state. And then the local agencies also have some responsibilities. So CJIS doesn't just apply to, note that I don't just say local law enforcement agencies there. The reason for that is that it doesn't just apply to criminal justice and law enforcement agencies. It actually applies to anyone that receives FBI criminal background checks. So you think about school teachers, school districts, daycares, nursing homes, and we'll go into a little bit more of where those authorities come from to access CJI, but that's where the local agency comes in and kind of makes some of their own risk-based decisions in how the policy is actually going to apply to their individual applications and service providers. And the whole policy is actually rooted in Title 28 CFR Part 20. So when we look for guidance on the policy and some of the definitions that are included in the policy, we can actually go back to the Code of Federal Regulations to get more details there. So now looking at FERPA. FERPA is the Federal Education Rights and Privacy Act. The oversight is provided by the U.S. Department of Education, but this is also where individual states come in. And so one of the trends that we're seeing at AWS is that we're seeing more and more states kind of adopt their own state laws that are FERPA-like. They may have some additional requirements that they put on the education agencies and their supporting partners, but ultimately, we see a lot of the states push back to FERPA, but we are seeing this emerging trend where states are going and passing their own laws as well. FERPA is actually in the Code of Federal Regulations as well under Title 34, Part 99. So looking at a comparison between the two, looking first at protected data. So there's two types of protected data that are identified under the CJIS security policy. The first is what we call CRI, or criminal history record information, and the second is criminal justice information. So the difference is the criminal history record information is anything that's related to, as the term may imply, criminal history records related to an individual. So there's really kind of a couple different parts that make up criminal history record information. You have to have something that identifies a particular individual and their involvement with the criminal justice system. So that may be a police report, right? That may be an incident report that says this person was arrested on this date and time, and here are the charges. So we have personal identifiable information and a record of their involvement with the criminal justice system. CJI is kind of a more of a catch-all term for all of that other information that's provided by FBI CJIS to the law enforcement agencies. So this may be biometric information. So you think about irises, fingerprints, facial recognition images, those kind of things. And then you also have things like warrants that have been issued by a judge, stolen vehicle records, property records, all of those things would be considered criminal justice information. This policy applies to all agencies receiving protected data from the FBI CJIS. So again, that applies to non-criminal justice agencies as well. And non-criminal justice agencies actually have a separate governing body called the U.S. Compact Council. And the Compact Council oversees the specific rules as they apply to non-criminal justice agencies. So it's been kind of interesting to watch the evolution of this policy over the last several years, because as we've tried to apply these security controls to daycares and nursing homes and school districts, you can imagine the challenges that come around that, because they're dealing with very small operations and very small implementations. And a lot of times it's just a filing cabinet that they keep it in, and we just got to make sure that the keys are kept secure and they know who has access to the keys to the file cabinet. But it scales all the way up to technology, and we actually are seeing a lot of cloud adoption in the non-criminal justice space as well. The data protection requirements under CJIS, there's hundreds of prescriptive controls. And these prescriptive controls historically have applied to those applications and databases where the data is actually being stored. There's a little bit of ambiguity as it relates to protection of the underlying infrastructure. However, there have been changes made to the policy in the last several years. In Section 5.10, for example, where it gives pretty clear guidance when operating in a virtualized environment, what additional controls need to be in place to secure that virtualized environment and partition it off appropriately. Audits are performed on a triennial basis. So the FBI, the way CJIS audits actually work is that the FBI will come out and audit each state every 3 years, and that involves an audit of the state CJIS system agency, basically making sure that the CJIS system agency is fulfilling their duties. And then they will select a random sampling of local entities, both criminal justice and non-criminal justice, to go take a look at. And again, those results go back to the CJIS system agency, and it's ultimately up to the CJIS system agency to resolve those findings. The state CJIS system agency is also responsible for auditing every criminal justice agency every 3 years. Now, on the non-criminal justice side, they actually have a responsibility to only audit periodically. They don't have the 3-year requirement for non-criminal justice agencies, but any criminal justice, so law enforcement, probation and parole, court systems, prosecutors, things like that, they are required to audit every 3 years. When we jump over to FERPA, the protected data is education records. So typically student data is where everybody puts the most emphasis. So again, kind of like criminal history record information, in order for it to qualify as education data, you really need to have the identifiers of a particular student or a particular protected individual, combined with some other type of data that connects them to an educational institution. So, grades, transcripts, sometimes student medical records. There's a whole lot of different records that you can imagine that the school districts maintain on students. So this would apply to all of those educational records. It does apply to all educational agencies and institutions receiving federal funding, and the data protection requirements are a little bit more ambiguous when it comes to FERPA. So there's no specific controls listed in FERPA. It refers to reasonable methods to protect the data. So we don't have as prescriptive controls as we do under CJIS, but reasonable methods can actually change over time, and it's kind of in the eye of the beholder as well. And audits are largely ad hoc. So we do see some FERPA audits. You may see state auditors' offices, for example, when they're going to audit a school district, they may loop in FERPA to include, but really it's kind of an ad hoc process. So when you think about the applicability in both of these, I want you to think about that it applies directly to the law enforcement agencies or the criminal justice agencies in on the CJIS side, and applies to the educational agencies on the FERPA side. But it also applies to any of their partners, any of their software vendors, any other contracted individuals. But really, ultimately, it's going to be these agencies that are responsible for ensuring that the policies are met as required. So this can extend out to partners and contractors as well, and certainly does. So again, with the comparison, access to CJIS data is permitted for a few different reasons. So one is the administration of criminal justice. So this is what we think of when we think of what cops and prosecutors and courts do. It's defined as activities related to the apprehension of criminals, the pre-trial, post-trial release information, the detection, the adjudication of crimes, all of those things that you would think about in the criminal justice system that are done. So if someone is performing the administration of criminal justice, they do have the legal authority to access this information. Also, you can access the information as authorized under state or federal law. So some states have differing laws saying who can be background checked. So, for example, most states have a state law that says school teachers, if not all, have laws saying that school teachers must be background checked. So that would be an authorization under state law where those individuals could be fingerprinted. So IT support in both of these, and I'll come back to this after I talk about FERPA, but it's important to note that IT support has always been kind of an exception to this, to say, well, if IT is supporting someone who is performing the administration of criminal justice, then that access to criminal justice information can extend to them. But I'll come back to that in just a second. So when we talk about encryption under CJIS, the encryption standard is kind of twofold. It used to be FIPS 140-2 compliant encryption was required for all encryption used for CJIS, both in transit and at rest. Just within the last couple of years, they also added in that you can use FIPS 197 at rest. So that brought in a lot of the AES encryption and brought that in to being an acceptable standard for at-rest encryption. On the FERPA side, access is obviously permitted for parent and student review so that they can understand what records are being held by the educational institution, and also for a legitimate educational interest. So this would be, again, we've got to prove that there's a reason for these individuals to access. Consistent with the principle of least privilege, we've got to prove that they have a legitimate educational interest to access the records that they're accessing. And again, under that, IT support has always kind of been an exception to say, well, these IT folks are supporting the folks with a legitimate educational interest, so they then can access this protected data in performance of their roles. So really, each time we look at IT support, one of the questions we need to ask is, can this IT support be provided or underlying support in providing an application or a platform or infrastructure be provided without exposing the data to them. And if it can, and we have a reasonable method to do that, then that's the route that we should take, not qualifying them for access to data that they really otherwise wouldn't need access to. So if the answer to that is yes, we can provide the service without accessing the sensitive data, then that should be our standard. Encryption standards for FERPA is, there's no specific standard beyond just reasonable measures again. So we don't have over here, like we have with CJIS, where it prescribes that it has to be FIPS 140-2 or FIPS 197 validated encryption. Over here, it's really just reasonable measures, which again is kind of challenging because it doesn't spell out the specific requirement. So both FERPA and CJIS require technical controls beyond just encryption to restrict the scope of who has access, and contractual and training requirements for who must have access. And must have access is the key point there, right? Is that we need to establish that in order for them to fulfill the terms of their contract, they have to have access to the data. If that's the case, and there's no way for us to prevent them from having access, then CJIS and FERPA both provide us a path to allow them to have access to the data. So looking at third-party access in this light, with CJIS in particular, CJIS provides us with two methods for data protection as it relates to the involvement of a third party. And it also relates to where the data is actually going to be stored or transmitted or processed. So if you go the route of contractual or physical protection of the data, we're working off of a few different assumptions. If you're solely going to rely on the contractual protection and the physical protection of the data, we're working on the assumption that the contractor has a legitimate operational need to access the criminal justice information in clear text and support the authorized agency. So again, the contractor is never by themselves going to be authorized. It's always going to be in support of that agency that's authorized under the federal or state laws. The other assumption is that the data will be stored and transmitted in clear text within the boundary of a CJIS-defined physically secure location. So under CJIS, there's this concept that says if you're not going to encrypt the data in transit and at rest, it must be maintained in a location that meets all of these prescriptive controls to protect the data. And one of those prescriptive controls is that everyone passes a FBI fingerprint-based background check, a federal and state fingerprint-based background check. The problem with this is it relates to larger scale, is that for software vendors, for example, in the public safety space that may be selling software in all 50 states, is that this isn't scalable. This isn't like they subject their administrators to one background check and they're done and they're qualified. They actually have to provide these fingerprints to at least all 50 states. And some states don't even allow the fingerprints to be done at the state level. They literally have to be fingerprinted by every customer that they have. So the idea of maintaining a physically secure location isn't as scalable as it sounds, physically secure location as defined by CJIS security policy. So I'll come back to that in just a second. If we take the technical and logical security approach, obviously we're going to meet all the requirements of the CJIS security policy as it relates to strong authentication, advanced authentication when accessing from outside of a physically secure location. We're going to meet all of those requirements in whatever CJIS compliant solution we build on top of AWS. But we're working off the assumption that the contractor has no legitimate operational need to know the CJI in clear text to support the authorized agency. So this is the case in the overwhelming number of cases as it relates to bringing AWS into the picture, is that we don't have an operational or a legitimate operational need to access the data in clear text. So this is why we're having this conversation, and part of where I'm going with this presentation today is that because we don't have that operational need to access the CJI, now a software vendor who's building on top of AWS certainly may need to go through that adjudication process and have the contractual language. But as it relates to AWS, we're actually empowering the customer to protect the data from anyone who wouldn't otherwise be authorized to access the CJI. We're also working on the assumption that the data will be stored and transmitted in an encrypted state. So if we can meet that threshold to say we can prove that the data is being transmitted and encrypted to meet that FIPS 140-2 or FIPS 197 standard, then it really eliminates the need to go down this contractual and personnel security route. So looking at this a little bit more in depth. So if you go the contractual or physical route, contractual and physical route, the compliance requirements are pretty complex. So it requires fingerprint-based background checks of all contracted employees with unescorted access to unencrypted CJI or access to a physically secure location. Now remember that in order to even get to this step, we need to establish that there is a need for that contractor to access the criminal justice information unencrypted. If we can't meet that standard where we've established a need for the contractor to access, then we wouldn't even go to this next step. But if we've already established that need, then the fingerprint-based background check has to be in place. Also, it requires annual or biannual security awareness training for all contracted employees with unescorted access to unencrypted CJI and access to the physically secure location. So this is not just your standard security awareness training, by the way. CJIS has a very prescriptive list of things that must be covered, and they're very specific to CJI in security awareness training. So just a third-party contractor just providing their employees with regular security awareness training, whether that be custom built or from another provider, isn't enough in most cases to meet this requirement. It has to be CJIS specific security awareness training. And this again can vary from state to state, making this column here very hard to scale. Physical security controls sufficient to protect CJI with regular validation of the CJIS-defined physically secure location. This one actually isn't hard for most people to meet because the physical security requirements that you would find in CJIS are pretty standard, and if you meet a high bar, you meet a high bar of complying with NIST requirements or FedRAMP or FISMA requirements around physical security, you're probably already meeting this definition for the physical security controls. Again, the complication with this comes into that everyone with access to that physically secure location must have a fingerprint-based background check at least 50 times, if not more. So that's what makes this requirement, again, difficult to scale. If we jump over to the technical and logical side of things, the compliance requirements are a little bit more clear and a little bit more simplified if we're using encryption. So the data will be encrypted both in transit and at rest. By the way, encrypted and in transit is always a requirement when it's going to leave a physically secure location. So think about physically secure location. When the policy was written, it was largely just the police station, maybe an off-site data center, and now it's been extended to the patrol car. They've actually extended it to say a patrol car is inherently a physically secure location. So it was never really designed to scale to the cloud. So if we look at data encrypted in transit and at rest, in transit is always required, but at rest is the addition that we're adding so that the data is always protected in a provable way by the customer in a cloud environment. And another important distinction is that CJIS usually calls out in the interpretation of the states that anyone with access to the encryption keys also is going to be assumed that they have access to the data. So this is where we'll get to when we talk about KMS, but we actually provide customers the ability to manage their own keys with customer managed keys. So that's an important distinction as well. When we take this approach, strong encryption becomes the primary data protection control, along with all those other access controls that we're going to have in place. Good port security, good network security, network segmentation, strong authentication, strong virtualization and partitioning of virtualized environments. All of those things combined with strong encryption now becomes the primary method of protecting the data, regardless of where the data physically resides, which is becoming, as we adopt new technologies, is becoming a harder and harder boundary to define anyway. And then the inherited physical controls, like all the physical security that AWS puts in place when we're building out our data centers, that's really still important, but as it relates to compliance in particular, those become secondary and complementary controls to the fact that the data is already encrypted. So under CJIS, it provides us this method to protect the data outside of the boundaries of a CJIS-defined physically secure location. But AWS customers get the benefit of it being in a physically secure location anyway. So as we look at FERPA, how this relates to FERPA, So the contractor must have a legitimate educational interest to access the educational data in clear text to support the authorized agency or institution. That again is our assumption. The data will be stored and transmitted in clear text. That's another assumption. So if we're taking the route of contractual and physical assumptions, then that's what we have to assume. If we go the route of technical or logical using encryption, the contractor has no legitimate educational interest to access the education data in clear text to support the authorized agency, and the data will be stored and transmitted in an encrypted state. And so as we look through this, with both of these requirements, both with CJIS and FERPA, I've talked a little bit around contractual, right? One of the requirements around this is that in two things: we have to establish that the person has a legitimate educational interest or a legitimate operational need to access CJI or FERPA. And if we do, we have to include terms in the contract around how that data is going to be protected. So CJIS handles that through something that's called the CJIS Security Addendum. And the CJIS Security Addendum is something that was written up by the U.S. Attorney General, and it talks about here are the responsibilities of any contractor who's going to directly access unencrypted CJI and what they need to do to protect it. Well, by taking the route of encrypting the data, we're actually eliminating some of those contractual needs, because the contractual terms will only apply to those contractors with direct access to unencrypted data. So you can greatly reduce. So I'll come back to that in just a second. So as we look through a little bit deeper on FERPA, the compliance requirements as it relates to going the contractual or relying solely on contractual or physical security, the reasonable measures are going to be inclusive of all contractors and personnel. So security and awareness training is how FERPA refers to it. That's required of anybody who's going to have access to the data. And again, I want to call out that we only get to these requirements once we've established that legitimate educational interest in accessing the data in clear text. Once we've done that, we'll run through these requirements. So there has to be contract language establishing the contractual control for the agency and the institution. So usually these contracts, as we go through them, talk about data ownership, talk about data privacy, all of which are kind of inherent to building on AWS. If you look at our standard terms, a lot of these things that would be required by a FERPA contract are already included, even though when utilizing encryption, there's no legitimate educational interest for AWS to have access to the data in clear text. So regular reviews of the contractors to determine compliance as well. So again, kind of an audit there. If we go over to the technical and logical side, again, it gets more simplified. So the data will be encrypted using strong encryption, and the encryption keys will be managed by the authorized agency. So again, assuming that anyone with access to the keys also has access to the data, we want the customer to be empowered to manage their own keys and make those keys only accessible to them. Strong encryption, again, becomes the primary data protection control, and any inherited physical controls are secondary and complementary. So again, even on the FERPA side, we're empowering customers to protect their data using strong encryption, and all of those physical security controls that are inherent to AWS physical secure data centers are complementary to that. So here's the advantages, and I've already spoken about a few of them. The advantages to using scalable encryption to comply, and I use the term scalable encryption because referencing back to why we're not doing this in the first place, in an on-prem deployment with a bunch of different technologies, encryption is not very scalable, and it's difficult to do because you have to maintain encryption using a lot of different interfaces, and more importantly, key management is incredibly difficult and provides the opportunity for mistakes to be made when protecting the keys. So using scalable encryption on AWS significantly reduces the number of personnel with access to your data, so it significantly reduces the scope of who you must include in that contractual language and all of the additional training requirements, all of the additional background check requirements, all of that significantly reduces. It also demonstrates the adoption of best practice to protect your data. So, we all want to reassure our regulators, we want to reassure the public who's protecting us with the information, we want to reassure parents and students whose information would otherwise be at risk, that we're doing the best that we can to protect this. And storing data in plain text in 2019 is becoming harder and harder to defend as a practice, because if you look at it and think about if your child's information was breached and the only protection that they had in place were some physical security controls or weak authentication. As security professionals, I know I would be very upset about that, knowing the availability of stronger data protection methods like encryption. It also empowers you with control over your own compliance and security. So by making sure that the data is kept in a compliant state and the keys are managed by the customer, it really puts them in the driver's seat of knowing not only, beyond just saying, well, we have this strong authentication. I'm actually one of the perfect people to be in a provable security position because I'm from the show me state. So Missouri's the show me state. I, as an auditor, would say, okay, you have strong authentication, you have all of this, but prove to me that somebody doesn't still have access to your data, and that becomes very difficult. With encryption and being able to just say the data is encrypted, and here's where we manage the keys, and I can show you a log of every time that key's been accessed, and I can show you a key policy in addition to our access control policies that shows who even has access to the key to decrypt the data. It becomes much easier to implement provable security and much easier to prove compliance with these requirements. It also, and again, that's kind of to my last point, is that it reduces compliance complexity. It gives us a provable mechanism to show, here's who has access to the keys, here's the strength of the keys, here's where the keys are being managed. So you all have, I'm sure, seen this. If you didn't see it before you came to Reinforce, you've certainly seen it at some point at AWS, and this is our shared responsibility model. So this is where we really define why this approach to compliance is possible, because we really empower the customer to manage all of the security related to protecting their customer data, which includes encryption. So we really take this model to heart, and essentially by making sure that the keys are managed in the cloud and managed appropriately, and we're giving you the tools and we're protecting that back-end infrastructure and providing you with strong tools to implement encryption, we really have a lot of success in empowering our customers to comply with CJIS and FERPA and all of the other regulatory requirements in a much more direct and simplified manner. So, talking about the methods to encrypt on AWS, we offer a few different methods, and it depends on the service that you're using and a lot of other things. Yes, I used the famous IT words, it depends, but we really provide you with a suite of tools depending on your risk appetite and depending on the services and tools that you're going to use both in AWS and what your administrators are already familiar with. So we offer for you to bring your own encryption. You can do client-side encryption. AWS actually provides you tools to do client-side encryption, or if it's as simple as using an S3 bucket, you're certainly welcome to encrypt the data on your own using your own tools and then upload to S3. I mean, it can be as simple as that. Obviously, client-side encryption does present some limitations in a lot of cases, but it is an option. The other option is our AWS Marketplace offers third-party providers. So I'm sure there's some vendors out here in the expo that are providing encryption tools that you can purchase through the AWS Marketplace. So if you have a tool set that you're familiar with, you can certainly use that. And then we have AWS native tools. But with any of these methods, effective key management is essential. As we discussed earlier, if you just encrypt the data, but you store the keys in plain text, or you store the keys right next to the encrypted data, it's going to be a problem. And really, it really takes away some of the strong protections that you get from encryption. So this is where I want to pivot over a little bit to AWS Key Management Service, or KMS. So, because key management is so critical if we're going to take this approach where encryption is the default and we're protecting the data from third parties, from insiders and outsiders and all those folks, we need to make sure that we're managing our keys effectively and in a scalable way that it doesn't make encryption a barrier to progress and to using some of the really powerful tools that you can use on AWS. So KMS provides a secure, resilient, scalable method to create and manage your own encryption keys. So we have the ability for customers to both use AWS managed keys, and in some cases that makes the most sense, but we also provide the ability to use customer managed keys. So in this case, the customer is in full control of those keys, and it is only accessible to the customer within KMS. So this is really one of the big things that empowers us to do this. KMS, by the way, was validated last year for FIPS 140-2 compliance. So the underlying hardware for KMS got that validation last year, which opened the door for CJIS customers to use KMS more extensively. All access to the key is controlled by the agency, by the customer or their trusted partner, and all of its use is tracked and auditable through CloudTrail. So every time somebody accesses that key, every time somebody interacts with that key, every time the key is used by a service, you can track all of that independently and validate that and prove that to your auditor. So that again goes back to the provable security. Again, you can show the auditor that you're managing your own keys. KMS has provable security to show who has access to those underlying keys, and more importantly, it's trackable and auditable on when the keys are used. This is where KMS becomes really scalable, because today over 40 AWS services have a direct integration with AWS KMS. So because of that, we have this list on our website that's ever growing of integrations with KMS, but it's a native function within those services where you can use your KMS customer managed key to encrypt your data. And I'll give you a couple of use cases. I'm not going to give you the standard use cases that you'd probably be most familiar with. I want to give you a little bit more obscure use cases with KMS. But the important part of that about this again is that we've already integrated KMS, a solid platform to manage your keys in a compliant way with both FERPA, CJIS, and a number of other public sector requirements with these 40 services. And another important part is that you can integrate with your own applications through the AWS Encryption SDK. So not only can you use it with all of our services, but we have an SDK that you can use to build your applications with an integration to KMS to encrypt your data within the application as well. So that's an important part as well. So when we look at the first use case, Amazon DynamoDB. So this is our NoSQL global scale database. And so DynamoDB integrates with KMS to support encryption at rest on server side with the server side encryption feature. So if you look with you give the order to DynamoDB to encrypt the data at rest, it actually reaches out to KMS to generate a table key off of your customer master key. And this is an important part of KMS as well, is that customer master key never has to leave KMS to go be exposed to a service. So really the service is just calling out to generate a data key, a table key, using your customer master key, and that customer master key is never exposed to that service, thus greatly reducing the blast radius of potential compromise of that customer managed key. So the table key is then used to encrypt the data encryption keys, which are then used to encrypt the data held within DynamoDB. So that's one that I could give you the examples that you're all familiar with using, probably all are familiar with, I should say, with using KMS to encrypt data in S3 or an EBS volume for EC2, but these are a little bit more obscure. The second use case is to manage application secrets. So as you probably know, being in the security community, an overwhelming number of the successful attacks against different companies and agencies are coming at the application layer, and a lot of this is just poor coding practices. So we've seen in the past where an application developer may store credentials in their code, which provides a real vulnerability and a real opportunity to the bad guys. So what managed what Secrets Manager allows you to do is to manage those application secrets. So you can use Secrets Manager to store SSH keys in a secured state. You can use it to store credentials that may need to be rotated. But beyond just storing them in application, or in Secrets Manager, which obviously gives you a lot of security inherently, we actually give you one additional step, which is that you can encrypt that information stored in Secrets Manager using your own customer managed key. So this is another kind of use case for KMS that most people wouldn't think of right off the bat. So again, the encrypted data key is used to then encrypt your secret value stored in Secrets Manager. So because this is really dynamic and these things change all the time, I really would direct you out to the KMS site. There's a lot of really good resources out there to talk about KMS, customer managed keys in particular, how it works, how security is provable with KMS, and then this is also the page where you'll see the list of services that integrate with KMS. And again, that list of services is growing all the time. So I would really encourage you to go out to the website and check it out. So that is that's the end of my presentation today. Obviously, in this format, it's not super conducive to question and answer, but I will be around afterwards if you have some additional questions. But hopefully, this has given you a little bit of insight as to how we can reduce that complexity in complying with these public sector requirements. Again, a lot of the complexity comes around not the technical side of things. We've got the tools available to us to comply with the technical side, but if we decide to go the contractual route, and why we don't recommend going the contractual route and instead going the technical route and protecting your data in a real, tangible, and provable way. If we decide to go that other route, we've got a lot of additional complexity that we have to work through, and certainly the technical and logical protection is not only a stronger security position, but it also allows us to comply with these regulations in a more simplified way. So thank you for coming, and I'll be around if you have any questions.